Well, howdy. Welcome to the first of a series of architecture talks, talks on the Galaxy code architecture. Um, Before we get going in, here's the slides are all available on the Training Materials website. Um, just how you can sort of communicate with the Galaxy project. There's a Gitter channel, Galaxy Project Lobby. Find us on GitHub, and then of course on Twitter. Follow Galaxy Project or use the use Galaxy tag. And I sort of use this slide a lot, but since we're gonna sort of start this talk about the architecture of the Galaxy code by talking about the social architecture of the whole ecosystem, I wanted to say that we don't just actually have one Gitter channel, we have a lot of Gitter channels. And so here's just some of them that are available on the Galaxy project, and then there's all sorts of Galaxy EU, IUC, Bjorn Biocontainers Training Network. I'll hopefully remember to mention some of these slides as we're going through the different projects that are part of the ecosystem and sort of tie those in. All right, so I've broken the different projects that are part of the ecosystem into, I think, 3 big categories of projects. User-facing applications, projects for plugin developers, and projects for admins. So let's start with the user-facing applications. And the most obvious one is Galaxy Project/Galaxy. This is the sort of main Galaxy application. The web interface, the database model, the job running. And this is what you came here to see. I will spend 2-3 hours worth of architecture discussions here talking about Galaxy Project Galaxy, mostly in this project, but I'm going to talk about these other ones first. So this is Python and ES6 for the most part. Cloud Launch powers HTTPS launch.usegalaxy.org. So it's an easy way to sort of launch web applications. It is a Python application built on Django. Yeah. The training material, presumably if you found this, you know what the training material looks like, but it's a sort of great way to start, it's a great way for many people to contribute to the Galaxy ecosystem. Developers and admins can contribute, but so can sort of scientists and application developers. If you're writing a workflow, scoping out some analysis type in Galaxy, this is the best way to sort of contribute that to a sort of broad community of people. And you can find that at Galaxy Project training material. The framework itself is it's mostly Markdown. The slides and the tutorials powered by Jekyll, so it's a Ruby backend. We've got another sort of documentation hub, the documentation hub called Hub. But the Galaxy Hub, it's a community and documentation hub for the Galaxy project. It's maintained by the community through this GitHub repository. It's another static website that's built with Metalsmith, with a Metalsmith static site generator. So it's a different backend that's node-based. Yeah, and it powers galaxyproject.org. Yeah, so another good place to contribute. So I guess I'm calling BioBlend a user-facing application. Okay, so if you want to consume the Galaxy API, if you want to drive Galaxy automatically, you want to integrate it into your own web app, if you want to integrate it into a command line application or some script you're writing, BioBlend's a great place to start. It's the official Python client for the Galaxy, the Toolshed, CloudMen APIs, and it's the best documented path to scripting the Galaxy API. There's training material around it. There's a Gitter channel. It's Python 3 based. Supports many old versions of Galaxy, so check it out. It's worth checking out even if you're not writing your client in Python. because it's again, it's the best documented path for scripting the Galaxy API. So it's it's worth modeling whatever language you're using. It's worth modeling that client around, I think. There's a couple other language bindings for Galaxy. The best maintained of these is for PHP. The Triple project puts this together. Blend for PHP. Yeah, so that's exciting. I years ago wrote this Blend4j project when I was writing a Java application that interacted with Galaxy. The team in Canada has taken it over, but it's I think sort of lagging and showing its age. So it might be best to just start from scratch if you're running a Java application, but there are some ideas in there worth looking at. Even older is the Clojure API, sort of based on Blend or BioBlend by Brad Chapman. I would assume this is completely unmaintained at this point, though. Oh, 6 months ago. Oh, wow. That's awesome. Never mind. I mean, everything Brad does is amazing. Another sort of user-facing application is CloudMan. This is basically the app that you get when you use Cloud Launch. The thing that is launched is Galaxy CloudMan inside of a Kubernetes cluster on the cloud. And so CloudMan it manages a cluster, gives you sort of an admin panel view of the cluster. Yeah, something worth checking out. And so those are some of our applications for the cloud and for like Kubernetes environment. There's also Bjorn's Docker Galaxy Stable, which is more sort of a Docker-centric, it's a Docker file, right? So I mean, yeah. So I mean, it's a different sort of perspective on how to containerize Galaxy, not tied to Kubernetes. So they built high-quality Docker containers for stable Galaxy environments. Lots of great documentation. Many flavors are available, so it's a cool component to sort of hack on and build different flavors of Galaxy for. Yeah, great documentation about how to run it. And its sort of default is a single, a single large sort of thick Docker container, but there's a decomposed version of it in here, including documents for running it on Kubernetes. So yeah, two competing ways to sort of get access to a containerized Galaxy version. Both great. For plugin developers, there's a set of projects up here for plugin developers, and if you think Galaxy plugins, hopefully the first thing you think is tools. It's the first thing I think. The tools IUC is a big set of Galaxy tools maintained by the Intergalactic Utilities Commission. Mostly high quality core tools for, you'll find a lot of these tools on Galaxy main. Use galaxy.org, use galaxy.eu. And it's also this repository, it's got so many eyes and so many like great developers working on it. It's a good demonstration of current best practices around tools. So definitely check this out if you're into tool development. It's a great asset. Again, here is one of the examples of those, the Gitter channels. So definitely subscribe to this Gitter channel if you're interested in tool development, even if you're not, contributing to Tools IUC directly. Some older tools, sort of maintained by the same team though, are available on Tools Dev Team. Those repositories, along with Bjorn's repositories, are examples of big repositories with lots of different kinds of tools in them. Peter has some great repositories that are more built around a single suite, and so this might be more your style if you're building a small set of tools for a single application. These are some great examples. Great paper from Peter on the BLAST repository. And then some others. Greg Van Kooster is a very prolific Galaxy developer. The proteomics team has a cool set of tools for doing proteomics analysis on Galaxy. Canadians do great work. So check them out. If you are interested in Galaxy tool development, I think Planemo is a great place to start. I'm biased though, but it's a command line set. It's a set of command line utilities to sort of assist developers of Galaxy tools. And I guess these slides are a little bit old because it's for all sorts of Galaxy plugins. So you can build training materials from workflows with Planemo. You can lint workflows with Planemo. But it's sort of core initial functionality, and the way it's still used the most is for linting, testing, and deploying tools to the toolshed. We talk about the training network and Galaxy Hub. Another important piece of documentation, I think, are the Planemo docs. This is, I think, where to get started with building tools. There's a quick start for installing Planemo, but once you have, definitely check out how to build Galaxy tools. Sort of an example-based approach that walks you through the basics, conditional parameters, wrapping scripts, macros, and then advanced topics. How to test tools, how to work with collections, how to work with Conda, how to work with containers. So this is going to be a sort of good asset for tool developers in Galaxy. Another project on GitHub is Planemo Machine, which is it's another Dockerized Galaxy environment. This one is different in that it's not meant for production or users who are running analysis. This is a Docker environment for developing tools. Not the Docker environment, but a virtualized environment. There's a Docker container, but the virtual images are more used. We use these a lot for trainings. StarForge is a framework that we use to build Python wheels for Galaxy. For the most part, you probably won't need to use StarForge. The reason why you might need to use StarForge is if you're adding a dependency to Galaxy, a Python dependency, and there aren't wheels available on PyPy, then we'll probably work with you on getting them published in StarForge and deployed to our custom PyPy server. It's important that the wheels that we sort of depend on are binary, so you don't have to have GCC and stuff installed in order to run Galaxy. And so StarForge is sort of our reproducible build environment to get us there. These last set of repositories are for deployers and admins. We have what must be dozens of different Ansible repositories. Maybe it's not dozens. Maybe it's just a dozen. It's probably dozens. Ansible components for almost every aspect of a Galaxy installation and maintenance. We use it for usegalaxy.org. The rest of the Use Galaxy Star projects use Ansible. It's a configuration management system with a lot of advanced features. So the Ansible roles are defined in various packages: Ansible Galaxy, Ansible Toolshed, Ansible Postgres objects, etc. And then the playbooks that sort of combine these roles together into actual sites and such are on Dash Playbook. And so there's some available from both Galaxy project and inside the usegalaxy.eu namespace on GitHub. Yeah, so these are important assets for people putting together Galaxy deployments. If you're interested in doing this, we have training for admins specifically that go into deep dives on this. And so there's training material available on the training website, and we also have yearly events. We have them at the BCC, GCC, and we have standalone week-long events. So definitely think about doing that if you're interested in sort of building a best practice Galaxy with these playbooks, and you want to really get into depth on how to do that well. Pulsar is a distributed job execution engine for Galaxy. So most of the Galaxy job runners that are distributed with Galaxy will assume that Galaxy has a big sort of central file system that all the worker nodes have access to. Um, Pulsar is the tool I developed to let you get away from that requirement by shipping data, scripts, and configuration for jobs to remote servers and running them. Can run jobs on Windows machines, can act as its own queuing system, or can access other DRMs. But this is what's needed to sort of get away from that requirement that Galaxy has a shared file system. It's a Python project. Yeah, it's got its own set of docs, so check them out. Yeah. Oh, I've been to mention some Gitter channels. So if you're interested in these admin components, probably the Gitter channel to check out is Galaxy Project Admins. Ephemeris has its own Gitter channel also though, and so what is Ephemeris? It's a library and a command line set of command line tools for managing Galaxy plugins. So tools, index data, and workflows. And these are plugins that are these are management tools that leverage the API, Galaxy's API. So it's a layer on top of BioBlend, and so it's useful utilities. So I want to take this directory and turn it into a library. I want to import this workflow for my users and install the tools. I want to take this YAML description of tools to install and run the tests on them after they're installed, that sort of thing. All of that stuff that would be useful for an admin is inside of Ephemeris. And I should say that Ephemeris is one toolkit for admins, but GXAdmin is another. A great set of tools put together by Helena. So Ephemeris is implemented in Python. GXAdmin is a set of essentially bash scripts. And there's a ton, and they've got great documentation here for the scripts. So yeah, there's a million little commands. Every time Helena or Nate, decide they need to run a Postgres query on Galaxy, and if they ever think they're going to run it again, they put it together and they document it. Some great stuff. You might be asking, why do you have Ephemeris and GXAdmin? I mean, some of that is probably pure accident, but they do have slightly different sort of requirements and design philosophies. Ephemeris is meant to talk to the Galaxy API and is a pure Python project, whereas GXAdmin is a tool that's going to talk to the same objects that Galaxy talks to, right? So it assumes it has direct access to the Postgres database, for instance, or it assumes it can read Galaxy's files. So GXAdmin, I think, is less interested in talking to the API and sort of using Galaxy interfaces and more interested in being like a toolkit that lets you access Galaxy's internals in a smart way. So Ephemeris can be used, I think, remote from the Galaxy server, as long as you have an API key that has admin rights, whereas GXAdmin is meant to be run right on the Galaxy servers that are hosting the Galaxy servers. A couple friends, I put this slide together because these are two really important projects for Galaxy development, both for developers and deployers. But I should say we have many friends of the project, right? Like there's a million open source projects that go into making Galaxy possible. I think that these are just two that you're more likely than not to encounter if you start working with Galaxy in a significant way. And they're on the next slide here, so I had to mention them. But they're Conda for recipes. So we use Conda to sort of it's our best practice standard for implementing Galaxy tools, like the actual underlying applications that we submit via batch processes. And then biocontainers package up our Conda environments and build containers out of them. We've got whole training materials about tool dependencies in Conda and tool dependencies in containers, and so you can check those out for more context. But I did want to mention them before this slide. which Freiberg put together, that sort of shows the whole ecosystem in one shot. So from biology to development to packaging to deployment, documentation, training, and support. Oh no, I thought I fixed this. Anyway, you start with a scientific questions. Answering it will require numerous underlying tools. Hopefully you'll find these tools have Bioconda packages, or you'll need to write one. Bioconda packages are sort of built and ship with the Conda packaging environment. From these, we sort of build biocontainers and put them on Quay.io. And then once you've got the underlying tools that you're going to run packaged, you're ready to sort of enter the Galaxy ecosystem. So we've got this cargo port project that I didn't mention, but it's for maintaining caches and backups of our things that we depend on. We use Planemo to build a tool wrapper, publish it to the toolshed with Planemo. Ansible to sort of deploy those tools to a Galaxy instance that we manipulate with BioBlend. We can build from an instance a flavored Docker image. The image can target a HPC server or cloud, being CloudMan, or Pulsar, target a remote server. Then it comes time to documentation. We've got the community hub, we've got the training network. We've got Gitter, GitHub issues and PRs for help, and we also have this help.galaxyproject.org where you can ask questions. We use Zenodo for publishing training material, input data sets, and stuff. All right. But for the rest of the project, for the rest of this talk, I'm going to go back to Galaxy Project/Galaxy and talk about those things. All right, thank you.